Today, we're diving into a really fascinating paper that tackles one of the biggest questions out there in AI safety. What it provides is some of the most encouraging evidence we've seen to date for a technique called debate, which could be a powerful way to align the super capable AI systems of the future. Okay, so let's just jump right into the core of the issue. The central problem is this. As AI models get smarter and smarter, eventually reaching superhuman levels of knowledge and reasoning, our classic methods for supervising them just aren't going to work anymore. Think about it. If we humans don't know the right answer, how can we possibly check an AI's work? Exactly. And that's where this paper offers a really interesting path forward. So here's how we're going to break it down for you. First, we'll really dig into this idea of the scalable oversight problem. Then we'll walk through the clever experimental setup the researchers designed to put AI debate to the test. After that, we'll look at how they managed to measure success without knowing the right answers, which is super cool. And, of course, we'll cover the key findings for both AI and human judges, and then wrap up by talking about what this all means for the future. Right, so let's start with that fundamental problem. Our current alignment techniques, like reinforcement learning from human feedback, RLHF, they all depend on humans being able to tell if a model's output is good or bad. But what happens when the model is an expert in, say, quantum chromodynamics, and the human supervisor, well, isn't? The supervisor can't provide that reliable feedback anymore. We just need a whole new playbook. And this brings us to this key concept, scalable oversight. The whole idea is to find methods that actually get better as the AI gets smarter. We want a system where weaker supervisors, whether that's us humans or just less advanced AIs, can still effectively manage much, much stronger expert AIs. It's all based on this core idea that it's often way easier to spot a correct answer than to come up with one from scratch. Exactly, and that's the very premise this paper puts under the microscope. To really simulate this whole expert versus novice dynamic, the researchers came up with an experiment to see if a judge who's totally in the dark could figure out the truth just by watching two expert AIs argue. So here's how they did it. They used the quality dataset, which is basically a bunch of complex questions about long stories. But, and this is the really clever part, they created what they call an information asymmetry. The expert LLMs get to read the entire story, but the judge, our non-expert, doesn't. All the judge sees is the question, two possible answers, and whatever arguments the experts make. It's a brilliant way to simulate a real-world scenario where the AIs have access to way more information than the human overseeing them. Okay, so the researchers test two main setups here. First up is debate. This is adversarial. You've got two expert AIs, each one assigned to argue for an opposing answer. They go back and forth, and the judge just has to decide who made the more convincing case. Then, as a baseline, they test a non-adversarial setup called Consultancy. Here, there's just one expert AI arguing its case, and the judge's job is to poke and prod with questions to figure out if it's telling the truth. And this diagram here from the paper lays it out really clearly. You can see debate has those two dueling experts with the judge just picking a winner. In Consultancy, on the other hand, you can see it's a one-on-one conversation where the judge is trying to verify what the single expert is saying. It really highlights that core difference, adversarial versus non-adversarial. So this whole setup creates a really interesting challenge. I mean, if your whole goal is scalable oversight, you can't rely on having the correct answers to train your models. If you already had the answers, you wouldn't need the debate in the first place, right? So the big question becomes, how do you improve the system without a ground truth answer key? And the solution they came up with is, frankly, brilliant. Instead of trying to optimize the models for correctness, they optimize them for persuasiveness. They use an ELO rating system, just like in chess, to measure a debater's skill based entirely on who wins and who loses in these debates. And the really crucial thing here is that this ELO score is totally unsupervised. You don't need to know the right answer. You just need to know which argument the judge found more convincing. Okay, and this is where things get really, really interesting. With this whole system in place, the researchers could finally answer that million-dollar question: if you make these debaters more and more persuasive, does it actually help a non-expert judge get closer to the truth? Let's take a look at the data. All right, so this chart shows the core results, and they're pretty stark. Let's look at the GPT-4 Turbo Judge first. A random guess gets you about 48% accuracy. The consultancy setup improves that to 54%. But look at debate. It skyrockets to 76%. And what's really amazing is that the same pattern holds for human judges. They reach an incredible 88% accuracy with debate, which just blows the other methods out of the water. So this leads us to what is probably the single most important takeaway from this paper, at least for the debate protocol. It's a bit counterintuitive, but when you take these expert models and just train them to be better arguers using that unsupervised ELO score, it actually makes the non-expert judge more accurate. In this setup, persuasion really does become a proxy for truth. And this chart shows that link plain as day. You can see on the x-axis, as the debater's skill, that's the ELO rating, goes up, the judge's accuracy on the y-axis climbs right along with it, from around 74% to 80%. It's a clear, strong, positive correlation. The better the debaters get at arguing, the better the judge gets at finding the truth. It seems that in a true adversarial setting, just being truthful is a really, really persuasive strategy. But, and this is such a fascinating twist, when they did the same analysis for the non-adversarial consultancy setup, they found the complete opposite. Making a single expert more persuasive actually made the judge worse at finding the right answer. And yeah, this chart shows it so clearly. As the consultant's skill goes up, you can see the judge's accuracy actually drops from 61% down to 57%. It's a negative correlation. So what does this tell us? It suggests that without an opponent there to call it out on its mistakes, a more persuasive consultant just gets better at confidently arguing for the wrong answer, and it successfully misleads the judge. The results with human judges are, if anything, even more compelling. I mean, look at this bar chart. Debate gets human judges to an incredible 88% accuracy. That's a massive jump, not just from the coin flip baseline, but also from the 78% they got with consultancy. It really suggests that the power of this adversarial setup isn't just some weird quirk of LLMs, it works for human reasoners too. And here's a perfect qualitative example of what that human reasoning looks like. In this case, the debate was about when a certain conversation took place. One debater was trying to sort of mush two events together, but the other correctly laid out the timeline using direct quotes. The human judge was able to follow the evidence, spot that contradiction, and conclude correctly that the talk about isotopes happened at dinner, not on the hike. This is exactly the kind of critical fact-checking debate is supposed to bring out. So let's pull all of this together. What does this actually mean for the future of AI alignment? I mean, these findings are incredibly promising, but it's also really important to be clear about the context and the limitations here. So the key implication seems to be this, that adversarial pressure is the secret sauce. It forces every claim to be backed up with evidence and shines a spotlight on any lazy or faulty arguments. This structure basically takes the raw optimization power of the model, its drive to win the argument, and channels it in a direction that ends up being truth-seeking. And that is a really powerful and hopeful result for this whole idea of scalable oversight. Of course, we have to be really clear about the caveats here. For one, this experiment only simulated an information gap, not a reasoning gap. The judge was just as smart as the debaters, it just didn't have the text. Also, these models have already been trained with RLHF, which means they're kind of predisposed to be honest. A really big one is that the whole system depended on a quoting tool that let the judge verify evidence. And finally, these results are just for a reading comprehension task. But even with all those limitations in mind, this paper is a huge step forward. It takes the idea of debate from being this cool theoretical concept and gives it some real, solid, positive evidence. It shows that, at least in this kind of setup, debate actually can help a weaker supervisor effectively oversee a stronger expert. And that leaves us with this final, really provocative question. For years, the AI alignment field has been focused on directly training models to be truthful and helpful. What this paper suggests is maybe a completely different path. Perhaps if we can just construct the right kind of adversarial game, we can just optimize for persuasiveness and let the structure of the game itself do the hard work of steering the models toward truth. It's a really powerful idea, and it definitely opens up a very exciting new front in alignment research.